Yeah, today's talk is quite interesting because for quite some time we've been running a secret project in Evolution Gaming, which was released in October. So this conference I can talk about the way this project's been done and share some insight from the process and some challenges we faced. I'm not sure it's going to be mind-blowing. It's just a day-to-day job of 3D React developers, which is also interesting. So yeah, my name is Denis Radin. You may find me as a Pixels Commander on social networks and GitHub. And I've been doing computer graphics for quite some time. I started in 1991 with the ZX Spectrum, which is a quite old beast, with a very special graphics video card. So the whole screen was divided into 8 by 8 pixels fragments, and every fragment was able to have only 2 colors of 8. So the whole system had 8 colors, and every small tiny bit of, you see this egg is changing the color when it moves from cell to cell. This is because of specificity of graphics adapter. And then you need to be clever in the way to use just 2 colors for 8 by 8 pixel cell and make a nice picture. And some people get perfect in that. So yeah, that's something I started with, and I switched to C++ just to try this more adult language. And then I switched to Delphi with DirectX support. I was doing quite interesting games there, but it was mostly for fun. Then my first commercial experience was C#, .NET, not that bad language, with a GDI plus interface for drawing graphics. I was working on a CAD system, so the whole vector engine for something like Microsoft Visual or Corel was developed by me, a few more people. Yeah, it was a lot of fun. Then we switched to Flash, and actually did pretty good there. We got to the showreel of a graphics engine. Let's go in a different approach. Yeah, this is something we developed. It's our game. It is 2010, guys, and it was running on the web in a browser. 2010. Imagine that. It was this was mind-blowing by the time. All right, so then journey proceeded. So I was one of the first who found that HTML5 have amazing potential to build games, and I open sourced and built one of the first HTML5 canvas graphics and game engines called FlashJS, and it was an inspiration for many Flash developers to move from a Flash platform to HTML5, because it was obvious that you can build quite nice things with JavaScript. Sure, will it work? It's almost 10 years game. Yeah, it works. So, yeah, the benefit of engine, it was very familiar API for Flash developers. Still works. Crazy, 10 years passed and it's still not broken. Because browser API changed like every year. For the last 8 years, we had so many changes, but this one still works. It's cool. Then I was working for a biggest in the world internet provider, working on performant UIs developed with WebGL. So the problem was, and the challenge was, we bought 4 million, not me, but the company bought 4 million of devices which had not that much of calculation power, not that much of resources on CPU, GPU, and we've tried to optimize UIs to run smoothly, which was a challenge, and the whole operation system was built on top of browser, on top of WebKit by that time. So we switched to WebGL to develop UIs, and from there were some quite interesting experiments. We've been running WebGL to draw UIs, and then you can do all these interesting transformations for HTML content. So yeah, it was fun, and we succeeded quite a lot in making interfaces with WebGL. But I also felt a lot of pains working there, so we tried to build. It was my first try to build a React declarative WebGL rendering engine, and yeah, I will get back to it in the presentation. And now I work in Evolution Gaming, where since last year we got the Amsterdam branch where we develop 3D games. Until now it was secret. Now it kind of okay to show. It's a gambling. Yeah, everybody probably knows what Evolution Gaming is doing, but we are trying to keep it very high level graphics. It's not the latest version, just what I have on YouTube, because running the build now is not possible for some reason. You see these reflections and some physics lightning, physics-based materials. It's quite nice, and it's getting nicer every day. Oh, and here I want to share the biggest secret of building amazing 3D graphics. To build AAA 3D graphics, you need AAA 3D artist. That's all. So who is not interested in technical details and challenges, you may leave the hall. You know the secret. So AAA 3D artist is something you really need to have on a team to do amazing 3D stuff. Yeah, actually, based on information I have, this is one of the most sophisticated 3D app ever built. So it's a 20 people team working for almost 2 years on that. It's definitely there are applications like Google Maps, which are more advanced, but I can't count this completely 3D. And we know that Google is like, it's really hard to compete, but after Google, we probably the second one. So the challenge is to have a 3D layer and UI layer. Why? Because we have also live games, which are video stream games, and we want to reuse React components from there. And actually, what I found developing UIs with WebGL, that WebGL pretty much sucks in building UIs. It's very cool when you do some 3D stuff, some effects, but building UIs with WebGL is pain. Yeah, so we have two layers, and for UI we use React, just simple React. For 3D we use, what should we use? BabylonJS or 3JS? Oh, do you know both of them? Yes? Babylon, yes, of course. But why? Yeah, it's also true. It's also true. Oh, there are some reasons which are also developed historically. 3JS was one of the first, or probably the first, WebGL engine which got some traction, and it had a huge community, basically oriented on making demos, like small demos. And this community, first of all, dictates author how API should be built, and then it dictates what the engine should be built for. So 3JS, even it's way more popular now, it's have compromised API, which is aimed to build demos, not games, not big applications. And BabylonJS is more up to date. It have TypeScript definitions by default, and it's pretty well structured. There are more reasons. They will pop up during the presentation further. Yeah, telling more about BabylonJS. There are quite some cases here. I don't think it's all applications ever developed with BabylonJS, but the big benefit also for this engine, and there is a team on Microsoft which is dedicated to developing BabylonJS. So 3JS is developed by community. It's cool, amazing, but then BabylonJS is really getting money from Microsoft. So what it means for you as a developer, if you have a problem, there is a guy on a salary which is going to fix your problem. It's actually amazing. And Microsoft is not that bad nowadays. You know, they have GitHub and. So this was about 3D layer. Our choice for 3D layer was BabylonJS. Then our choice for UI layer is of course React. Otherwise, the presentation would be named differently, how to develop with Angular or whatever. But ReactJS was picked for the reason mostly that have the biggest ecosystem, and we already had a code base built with ReactJS for live games. We have a storybook with a lot of components, so it's quite natural Why we picked Redux? Oh, there are a few reasons. I personally hate Redux, but here it fits well for a few reasons. First of all, it was picked like 2 years ago, when alternatives were not that clear, not that many of them, and it is official, kinda. It was official. Now they're switching to context and hooks APIs, but there is another reason. When you build a game, it's not only about manipulating, getting data, and sending data. You can't build a game with GraphQL. It's going to be really hard, because the game is all about event streams. You push an action and something is happening on the screen. It's not just you getting data and displaying the data. And Redux is perfect here, because it allows both manipulating data and sending event to informing your application, working as an event bus. So we have a BabylonJS and we have ReactJS. How these two layers interact with each other? Oh, some of you might think that we build some kind of a wrapper, which is like 3D object, GSX 3D object tag, and then no, actually this is something we tried to do in Liberty Global like 5 years ago, and it didn't work. For the reason that once you try to put your 3 objects into React 3, first of all, React 3 is nice to reflect changes in a state just by rendering, but if you need a change in a state with animation or transition from a state to a state, it gets harder. There are some approaches to do that, like React Motion or React Animate, but it gets harder. And updates for React 3, they take time. So for us, React and BabylonJS components, they live in a separate renderers. So we don't have a declarative 3D tree. And it works perfectly. Once we tried to make declarative 3D tree in Liberty Global, we faced a lot of issues. So first of all, code base bloated because we need this additional layer. Second, it was not suited for making some transitions between states. So what we popped up here is that, right, we have React, which gets a state from Redux, and we have a 3D, which gets a state from Redux. So basically, 2 layers are connected with through Redux store. To understand how this works in practice, we need a little dive to how BabylonJS works. And the simplest entity for BabylonJS project, the one you build project of, a scene of, is a mesh. So the mesh is kind of HTML element of 3D world. Everything you put on a scene, like chair or card or whatever, is a mesh. Every object is a mesh. It have position, rotation, materials. So it's a graphics representation of an object on a stage. Every of these objects are meshes. Mesh, 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 and you can combine them. You can inherit them, and making a tree like HTML can do or React GSX can do. So the solution is to have a Redux mesh. This is the same 3D building block, but it's connected to a Redux state. It's a quite thin layer, just a wrapper which connects 3D object which already exists in Babylon to Redux. And it has the same lifecycle methods as React component have. So component mount, component will receive props, component will unmount, but instead of render, we have initial render, not to mess up, because we don't have this automatic reactive change of 3D content. So we render only once. We put, if this is a card, we create a model of a card in imperative way in initial render method. And once properties of object change with Redux, like map state to props, you all know that probably, then we react in imperative way. So if we see that card should be moved based on the state from one point to another, we run imperatively in component will receive props. We see that, and we run imperatively animation. So we serve changes in imperative way, but it's very close to React in nature. And it helps to keep this layer of communicating to 3D from React very thin. Yeah, just I already had this experience, and declarative stuff, declarative 3D, it's not flexible. It just doesn't work. Yeah, that's an essential how we build React application, how we sync with 3D, with UI. But aside from that, we have quite some challenges which are very specific to developing 3D application on the web, and also with React. So this one I was already talking about. Any 3D engine sucks in building UI components. And it's fine if you just need a label somewhere in a corner. You just can have another layer on top of 3D theme and just put a React component there. But what if you need to stick some component to some, for example, you need to make a tooltip for a button, and a camera constantly moves. So we popped up with a thing called I had the switching of so you see these indicators. Sorry, my kid is watching stuff. Yeah, so you see these indicators. They're just React components. They're connected to a state. They look for scores for a state, like it's dealer scores and the player scores. They look from a state. Just normal HTML React components. They just wrapped into HTML mesh component, which accepts 3D coordinate on a stage, and it sticks to 3D coordinate on a stage. In the way, then it's going to be scaled and manipulated to follow camera and to stick to a 3D position on a stage, which is interesting. It's done in a very simple way. Basically, on every request animation, we get a coordinate from a 3D engine through the matrix of transformation, which is like a projection point to a screen, and we update with a transform, scale, and it works. It works pretty smooth. So it runs with no problems on a mobile device. If you are like suspicious every request animation frame, it's not that hard transformation. If you know browser sucks in repainting things or relayouting things, but this one is very cheap, so no problems there for us. Second problem is performance regressions. So the aim is to have 60 frames per second, but developers do merge requests. They introduce new features, and every feature potentially hits performance in the way it has some regression. It was a big problem because one single feature doesn't hit performance a lot, and QA or developer can't actually track this regression. So you need some more precise system, and you need some more efforts to keep system out of regressions. So what we popped up with is a continuous FPS benchmarking, which tracks what is the performance, what is FPS, and other smoothness metrics after every merge request is got to develop. How it works? It works first of all on top of functional testing. You know, this, scenarios run by in a browser. So you run a script for scenario like press this button, and then you have a scenario. You all are familiar with automated tests, right? Then on top of it, our automated tests are running on WebDriver IO. And for WebDriver IO, we have additional Cucumber step, which injects small script into browser which run automated test. And this script tracks timings of every frame. Like users request animation frame to check timings, to check the interval between frames. Once frame is dropped, it stores it to a memory, and then by the end of a scenario, it reports. It reports average FPS, it reports number of dropped frames, the total time of dropped frames, and the longest sequence of dropped frames, which is quite important metrics, because if just one frame dropped, it's not a big deal, but if you have 10 or 20 dropped frames, which happens, then it produces a very unpleasant experience for a user. So then we started to report to Jenkins benchmark plugin, which was cool because we don't need additional infrastructure for reporting. But then we found that our CI/CD people would like to get rid of Jenkins plugins as much as possible. Now we are refactoring to a Google Data Studio. Actually works. We are in the process of doing that. Another topic which popped up, and it's also connected to performance, is that we as developers and QAs have too good hardware. Like every time we test on a quite good hardware. For mobiles, we have some low-end devices, but for notebooks, no. But anyway, the problem is not enough testing with devices who have low performance. And there was an interesting case connected to that. In October, we launched the first of this RNG 3D games. It was a big success, and we deployed it to some casinos worldwide and started to do testing, and not like really not even bad. It was a real production. So just to give you an idea how this looks like. So it's a roulette, right? And then you put some money on red, you put some money on black, you bet, and then the wheel starts spinning. Let's get to a spinning of a wheel. So the problem was that on the high performance devices, it was completely fine. Then even less than 1% of users started to complain, hey, we put on black, we bet on black, the ball is on black, but you show us, because there is an animation of ball running. Oh, let me switch to YouTube. There is no timeline for can't scroll it to a point where ball starts to run. Yeah, so that's a ball. And a ball is a keyframe based animation. Oh, we found that for less than 1% of users who have low-end devices, the keyframe animations, and they have some dropped frames on their devices. A keyframe animation is not in sync with a wheel rotation. Wheel rotation is just a time-based thing, just a twin. And it happens that the ball should be on black, but it was on red. And people were saying, like, you are showing us that ball is on black, we bet on black, it should be a win, but you say us, you lose. And as people were crazy complaining about, hey, it's a wrong result, so we've been trying to fix the issue until 4 a.m. And then we found the problem, like we fixed it next day. But then, since then, we realized that we have too good hardware. And we should test. So that's a pipeline for you to understand what kind of efforts we have for testing. It's quite a lot. Like developers have testing, like unit tests, integration tests, and there is automated testing. There is a manual QA in a team, and there is additional team which is like tiger team of QAs on a product management side. And still, all this pipeline had too good hardware. So after this case, we popped up with a Chrome extension, which actually this Chrome extension allows to emulate drop frames and a low FPS. So now we can just switch. Okay, okay, interesting. Maybe we can use a FrontCon. Let's check. All right, it works. It's probably the first time when my mobile internet is worse than. Yeah, you just pick how much frames you would like to drop, and it starts dropping frames. You see, then yeah, you also can limit FPS to 30, 10 to. So yeah, we now have an emulation of shitty Android phones. One more problem for developing WebGL is designer-developer interaction. So, oh my God, it's wrong. Okay, let's imagine you have a new asset, and the designer just delivered it, but it can't try it in a real game. Oh, you can build your own toolkit, but then it's still a problem. You need to put some resources on building some utilities and tools. So normally it happens, and there is some developer efforts needed for integration. It's like a cycle. You have a new chair, you need to put it somewhere in a game, and then you need a developer refers to a product owner, and it goes with like checking one chair. If it fits a scene, it may take a day. But for game engines, which are mature and commercial game engines, this problem is solved by having very friendly, what you see is what you get IDEs. Oh, you probably all know Unity. Who knows Unity? Right, everybody knows Unity. So Unity solves a problem in a quite efficient way. They just have IDE like 3D Max or something, and it works. So designer can try before rolling out and show and discuss with the product owner. So yeah, it's a big benefit of this kind of engines. And we started to think, okay, maybe we should go Unity, because building this kind of tool belt, building this kind of IDE for BabylonJS might be a really crazy idea. Potentially it can be solved, but let's get back to it later. Another thing is assets reusing. And the case is, once we have to do a lightning is a game. It's a lightning roulette, and a similar thing, but there should be a special effect. Yeah, like lightning strikes numbers. Oh, actually, when we got this task, what we did, we went to internet. First we searched for some libraries for BabylonJS which can do that. No, there is nothing, of course. It's a very specialized kind of thing. And we went to internet. We found some slow motions of lightning striking into the ground. So we found all physics behind lightning, how lightning works. We read few tutorials for different languages, how you can build a lightning strike, and so on, so on, so on. So we ended up with building something quite interesting. And we spent around like maybe months on building this lightning. But then at some point I went to Unity store and I found this effect, which is amazing. And it's parameterized. You can set it off, and it costs $5. Can you imagine the difference? So yeah, Unity Store is awesome. So there is a shitload of assets for any kind of application, any kind of idea you have. They have skyscrapers, warfare, landscapes, spaceships, whatever. You just put a search word and you proceed, which is cool. I think the difference is, yeah. So this kind of possibilities like IDE and assets make you efficient. So we consider we should use Unity for building games, but Unity sucks with React. So we started to build a tool belt how we can use Unity in React. Yeah, because for UI we want to keep React. We don't want to build UI with Unity for a few reasons. First of all, we still have live games, video stream games, which have the set of components we use, like game history, betting buttons, some charts, and so on. We don't want to build it again in Unity. So how to use the best UI framework with Unity? So the first challenge we try to do, and we played around, just to integrate Unity into a React project. And we try to export few Unity projects to WebGL. There is a possibility that publish to WebGL, and it works in most of cases. And we popped up with a thing called React Unity. You can get it from NPM, actually open sourced, and it works in the way you publish something to WebGL. You have this folder. Then you include the component of this React Unity which you install from NPM, and you do something like that. It's very simple. Then you have your stage in React, and we were working further on Unity Redux middleware to propagate Redux events to Unity application, which you use inside of React app, and on a Unity dispatch. Until we found that the smallest package with Unity, just clear stage, it is nothing, even no sky. It's 20 megabytes. And for us it was not acceptable. Like once you start dropping assets there, it gets to not comparable. Like a roulette, all assets for roulette is around 28 megabytes. Oh, the roulette I was showing, 28 megabytes, and here it's only 20 megabytes of JavaScript which supports Unity runtime, which is silly. So we stopped these experiments until we get Unity Tiny. Maybe not that many people know, but recently in December, Unity announced a Unity Tiny, which is going to be another thing. No, not this one. Another thing which is aimed especially for the cases as we have. It's a tiny platform with the runtimes. It's built with TypeScript, so it's not a C# anymore. So you develop with TypeScript, and you publish for the web. And runtime is something like 100 to 200 kilobytes, which is definitely acceptable. It's currently in a preview. You still use the same IDE, so you have all benefits of Unity, but then runtime is optimized 100 times, they say. I'm not sure what they cut, but it's still not in public for 3D. You can play with 2D version. For 3D, it's not there yet. We are going to play again with Unity once it's back, once Unity Tiny is there. But what we found during our work further on games, that BabylonJS is progressing quickly. So they have this team which is getting paid, team of high-skilled engineers. And what they started to do, they started their own IDE built with React. So they built a web-based Unity IDE. I think I have a slide somewhere, not a slide, or at least link. It's BabylonJS. Yeah, this one probably no. Yeah, this one. So basically it looks very similar. They have an inspector and they have the explorer for a stage, and it's all built with React. They very easily accept feature requests. and it's getting there very quickly. So I think in a year or two, BabylonJS is going to have IDE which is very similar to Unity by possibilities. It doesn't solve the problem of having this lot of assets in the store. We are solving that. We are open sourcing our lightnings and all the things as much as we can. And yeah, it actually looks pretty much like a Unity IDE. So we are looking forward for both, for developing a Unity stream further as an experiment once Unity Tiny is there, and working with the BabylonJS as it's developed crazy quick. Oh, that's all from me, guys. Do you have any questions?
Questions?
Hi, excellent lecture. I love WebGL, especially in the combination of frameworks. Have you thought about porting this to WebVR or WebXR right now? Because you build so much, and I don't think it will be a lot of work, and you expand.
No, it would not be a lot of work. Basically, you have everything. What you should add is just a plugin for a BabylonJS, which is heavily developing now. I know that in Amsterdam on a conference in June is going to be author of BabylonJS talking, and his talk is going to be exactly, he is as an author of a framework, he's focused now on WebXR features, and I'm not sure what's there coming, but already it's quite easy to add a plugin and it works, but they're like, we are investing a lot into VR. I'm not sure what's coming there.
Yeah, thanks.
Hi, thanks for the presentation. It was amazing. So right now you're using WebGL stuff, but like compiling to JavaScript because of the problems you mentioned. So I guess already you could, like using Unity, compile to WebGL plus WASM, like WebAssembly.
Yeah.
But like there's no real way to control like or import WebAssembly from JavaScript modules. But like if that changes, what do you think like the package sizes and everything would be affected?
I'm not sure, because what will happen with WebAssembly is they will just park the whole runtime. It's not the matter of bad packaging. It's a matter of runtime is being too large for a web. So they should first change the product and then maybe WebAssembly helps by 20%, but it doesn't help me if the runtime changed from 20 to 16. It's still a shitload of 16 of megabytes just of a library, single library, yeah. And I need 100 of.
Thank you.
Oh.
Hi, it was a nice presentation. So I have a question about Redux. So you said that you're using Redux in combination of animations. So the question for me, are you sending action just to trigger the animation, or you actually updating the coordinates?
No, we don't do that. No, never do that. It's not what Redux.
Crazy, yeah.
Yeah, it's like many people trying to. This was a painful question. Like when we just started, many people were very dogmatic about Redux. We should have all state in Redux. And like some people were trying to convince the team to put all coordinates into Redux. But come on, if you know how Redux works and how many problems it can produce, performance problems, and just a mess in a state, so you would never do that. So with time, we get rid of this idea completely. So nobody now is trying to convince the team to put coordinates to Redux. Even more, there is an idea, which I'm not sure is going to happen. There is an idea to have or two stores for two worlds, like because animations happen more quickly and they need a bit different state management. But yeah, like there should be some separation. And how we run animations, getting back to the question, we run them as chunks. So you start animation and you put it. So we have a large promise chain in the game, which is a game sequence, and then you add the chunk to a promise chain, and then again and again. Yeah, it gets to quite big promise chain, but it works. Like it's with built-in mechanisms. There is some idea to work with a green sock timeline. It's not there yet, but yeah, promises works.
Alright, sorry, we're out of time. Come and say hi to Denis during the break. Thank you.
Yo, thank you guys.